The overall goal of this work is to generate micro and submicron patterns on the top, sidewall, and bottom surfaces of a polymer substrate for various applications. This is accomplished by first coating intermediate and target polymer layers on a rigid surface. Next, sharp and round-edged mold structures are fabricated and used to emboss the substrate above the glass transition temperature of the intermediate polymer, which is below the melting temperature of the target polymer. After the substrate cools, the mold is removed and micro and submicron patterns are revealed on the surfaces of the polymer substrates.
The biomedical applications of micropunching lithography are first, the PPY microwires generated with cutting operation are used for glucose sensing. Second, the HDPE channels generated with drawing may be used as microfluidic channels inside lab-on-chip devices for reducing the fluid flow friction.
In this procedure, a silicon substrate which is coated with intermediate polymer and a material to be printed is heated above the glass transition temperature of the intermediate polymer and below the melting or transition temperature of the targeted material. Next, the mold and the substrate are brought into physical contact under high pressure, followed by subsequent cooling. Lastly, they are separated when their temperatures drop below the transition temperature of the intermediate polymer, thus completing the pattern transfer from the mold to the targeted layer. For this procedure, fabricated silicon molds of the required dimensions must be prepared using conventional UV lithography. Prepare the intermediate layer by selecting a non-conducting PMMA sheet and place it on a rigid, flat substrate.